252 million years ago, almost everything on Earth died. Not half. Not most. Almost all of it. 9 out of every 10 species on the planet, gone in what counts, in geological terms, as an instant. The forests, the reptiles, the insects, the strange creatures crowding the seas. Whole branches of life that had survived for hundreds of millions of years simply stopped, all at once, and never came back. Scientists call it the Great Dying. It is the closest life on this planet has ever come to ending completely. Now, if I asked you to name the deadliest day in the history of the Earth, most people would say the same thing. The asteroid. The one that struck 66 million years ago and wiped out the dinosaurs. Fire, dust, a global winter. The end of an era. That extinction was real. But it was not the worst. And it was not even close. The Great Dying killed far more. It happened long before the dinosaurs existed. And here's the part that changes everything. There was no asteroid, no crater, no rock from space. Whatever did this came from the planet itself. So that is the case. 90% of life on Earth, dead. A crime scene from a world so old the dinosaurs had not appeared yet. And no obvious murder weapon. For a long time, that was where it stood. An enormous body count and no clear cause. But the thing about a crime this old is that the evidence does not disappear. It turns to stone. The victims become fossils. The conditions of their death get locked into rock, into teeth, into the chemistry of the ground itself. And over the last few decades, scientists have learned to read all of it. They have reconstructed most of the murder. They can tell you how hot it got. They can tell you what happened to the oceans, and in what order things died, and roughly how long the whole thing took. They have a prime suspect, a motive, and a mechanism. What they still cannot fully agree on is the final blow. What actually delivered the killing stroke to 90% of life on Earth is, even now, an open argument among the people who study it. One of them recently compared the whole thing to a murder mystery on a train, where the hard part is not finding a suspect. It is that there may have been more than one. So let us walk the evidence, and you can decide for yourself. To understand the death, you have to see the world that died. And it looked nothing like ours. Back then, there were no continents in the shape you know. All the land on Earth had drifted together into a single enormous supercontinent. A landmass so big it has its own name. Pangea. One giant piece of ground wrapped around the middle of the planet, surrounded by one vast global ocean. And it was not empty. This was a full world. A busy one. The seas were crowded with life that had been evolving for 250 million years. Reefs, though not the coral reefs you would recognize. Trilobites, those armored creatures that had crawled the seafloor since almost the dawn of complex life. Sprawling forests on land. And walking among them, the dominant animals of the age were not dinosaurs. Dinosaurs did not exist yet. The land belonged to early relatives of mammals, our own distant cousins. Some were squat and barrel-bodied. Some were predators with long saber teeth, hunting a world that had never seen a dinosaur. This was the established order, and it had been stable for a very long time. If you had stood on that supercontinent and looked around, you would have seen a planet that seemed, by any reasonable measure, to be doing fine. It was not fine. Something was already wrong deep underground, in a part of the world that is now Siberia. And it was about to surface. Let me put numbers on the dying, because the numbers are hard to believe. In the oceans, an estimated 96% of all species went extinct. 96. That means for every 100 kinds of animal living in the sea, roughly 96 vanished and 4 survived. On land, it was slightly less total, but still catastrophic. Around 70% of vertebrate species wiped out. Put those together and you get the figure that gives the event its name. Something close to 90% of all species on Earth, gone. It is worth slowing down on what that actually means, because 90% is easy to say and almost impossible to picture. That figure counts kinds of life, not individual animals. 90% of all the different species on Earth, entire families, entire ways of being alive, simply stopped existing, most of them never to return in any form. The trilobites I mentioned, the ones that had survived for nearly 300 million years through everything the Earth had thrown at them. This is where they end, right here. After this, there are no more trilobites, ever. Life on Earth has been through 5 great mass extinctions that we know of. This one is the largest by a wide margin. Scientists sometimes describe it without much exaggeration as the closest the planet has ever come to being scrubbed clean and started over. And it left almost no fingerprints, which is exactly what made it so hard to solve. So how do you solve it? You start the way any investigator does. You look at the obvious suspect first. And the obvious suspect, for any mass extinction, is an asteroid. We know an asteroid can do this, because one did, later, to the dinosaurs. That case is essentially closed. When a giant rock struck the Earth 66 million years ago, it left evidence that is almost impossible to fake. A thin layer of a rare metal called iridium spread in a line all around the globe. Iridium is scarce on Earth but common in asteroids, so a worldwide band of it is close to a confession. And eventually, a crater to match was found, buried off the coast of Mexico. Means, weapon, and signature. So the first thing scientists did with the Great Dying was look for that same signature, a worldwide layer of iridium, a crater of the right age and size, the telltale dust of an impact. They did not find it, not convincingly. People have proposed impact craters for the end of the Permian over the years, and one by one, those claims have failed to hold up. There is no clean iridium spike like the one the dinosaurs got. Nothing that points to a rock from the sky, which leaves investigators somewhere uncomfortable. You have the worst mass killing this planet has ever seen, and you have ruled out the one cause everyone reaches for first. Whatever did this was not an impact. It was something the Earth did to itself. And to find it, they had to learn to read the only witnesses left, the rocks. Here is where it becomes genuinely forensic, because a body that died 250 million years ago cannot tell you how it died. But it turns out the rock around it can. Think of it as a crime scene where every surface recorded something. Start with temperature. There is a tiny eel-like creature from that era called a conodont. Its soft body rotted away long ago, but it left behind microscopic teeth, harder than bone. Those teeth grew in seawater, and the exact chemistry of the water, the balance of different forms of oxygen locked into the tooth, depends on how warm that water was. Measure the oxygen in a fossil conodont tooth today, and you are, in effect, reading a thermometer that recorded the temperature of a sea from the deep past. Then there is the ground itself. In rock layers from this exact period, geologists find what are called red beds, bands of rusty red sediment that only form under hot, dry, oxidizing conditions. The color of the dirt is a record of the climate, and there is chemistry finer than that. The rock at the boundary between the Permian and the Triassic carries unusual amounts of certain metals, and telltale shifts in carbon and nickel, each one a clue about what was in the air and the water when the sediment settled. There are even spikes of mercury in the rock, a heavy metal that only enormous volcanic eruptions throw into the sky in quantity, drifting around the planet, before settling into the mud. Finding it laid down in sediments worldwide, at exactly this moment, is a little like finding the same residue at crime scenes on every continent. None of these witnesses says much on its own. But put them together, layer by layer, site by site, all around the world, and a picture forms. A consistent one. And the picture is grim. Everywhere the detectives looked, the same story was written into the stone. It got hot. Then the ocean stopped breathing. Then things started to die.
The question was, what turned up the heat? The answer was hiding in Siberia, and it is almost too big to take seriously. At the exact time all of this life was dying, one region of the planet was going through a volcanic event, unlike almost anything else in Earth's history. Not a single volcano. Not even a chain of them. A vast zone of the crust simply split open and began pouring out lava, on and off, for something like 1 million years. The scale is difficult to convey. By the time it was done, this eruption had buried an area of several million square kilometers in volcanic rock. Layers of it, stacked hundreds of meters deep, across a stretch of ground large enough to swallow much of a continent. Geologists call the result the Siberian Traps, and it is one of the largest outpourings of lava the planet has ever produced. But here's the crucial thing. The lava is not the murder weapon. The lava stayed in Siberia. It never touched the animals, dying in the oceans on the other side of the world. What killed them was invisible. It was what came out of the ground along with the lava. Because when you crack open that much of the Earth's crust, and when that magma pushes up through buried layers of coal and salt and limestone, you release gas. An almost unimaginable quantity of it. Carbon dioxide, sulfur, and more, vented into the atmosphere over centuries and millennia, faster than the planet had any way to absorb. The rising magma may have made it worse still, by cooking straight through Siberia's vast underground beds of coal and setting them alight. If so, the eruption was venting its own carbon, and on top of that, burning ancient fossil fuel on a continental scale. One estimate puts the carbon dioxide released into the tens of thousands of billions of tons. The number is so large it stops being useful. What matters is the effect. The Siberian Traps did not kill by burning. They killed by changing the AIR. And once the air changed, the planet did the rest. This is the part where you can actually follow the murder, step by step. It is a chain reaction, and each link makes the next one worse. It starts with carbon dioxide. We know, in our own time, that carbon dioxide traps heat. Put enough of it into the atmosphere, and the whole planet warms. That is exactly what happened, on a scale that dwarfs anything humans have done. Global temperatures climbed by around 10 degrees Celsius. Not in one place. Everywhere. 10 degrees does not sound like much until you feel it in an ocean. The seas heated up until, in the tropics, surface waters reach temperatures over 40 degrees Celsius. That is more than 100 degrees Fahrenheit. Bathwater. Water that hot is lethal to most sea life outright. And it drove the animals that could still move toward the cooler poles, abandoning huge stretches of a suddenly hostile planet. But heat was only the first blow. Warm water holds less oxygen than cold water. So as the oceans heated, they began, quite literally, to suffocate. Oxygen levels crashed across vast regions of the sea, creating what scientists call dead zones, stretches of ocean where almost nothing can breathe. This is called anoxia, and its fingerprints are all over the rock from this period. And then it got worse still. In those airless, stagnant seas, a different kind of bacteria thrived, the kind that produces hydrogen sulfide, the poison gas that smells of rotten eggs. The oceans did not just stop breathing, they turned toxic. In some places, the sea itself may have become a thin layer of breathable water sitting on top of a deep pool of poison. Hot, then airless, then poisoned,
That is the sequence written into the stone, and it is enough, on its own, to explain a catastrophe. But the deeper scientists looked, the more they found that the simple version was not quite complete. There were complications. And the first one involved an unlikely accomplice. The accomplice was a microbe. For years, one detail nagged at the investigators. The amount of carbon that flooded the system during the Great Dying looked, to some researchers, like more than the volcanoes alone could easily account for. Something seemed to be amplifying the effect, multiplying it. One leading suspect is almost absurdly small. A single-celled organism called methanosarcina, a microbe that, among other things, produces methane, a greenhouse gas far more potent, ton for ton, than carbon dioxide. The theory goes like this. The Siberian eruptions did not just release gas. They released metals, including a flood of nickel, into the environment. And it so happens that nickel is exactly the ingredient this particular microbe needs to shift into high gear. Give it enough nickel, and it can bloom and pour out enormous quantities of methane. So the picture some scientists paint is this. The volcanoes started the warming, but it may have been an explosion of hungry microbes fed on volcanic nickel that helped turn a severe crisis into a total one. A world poisoned, in part, by the smallest living things on it. Not everyone agrees on how big a role the microbes played. It remains one of the contested threads of the case. But it captures something important about the Great Dying. There was no single clean cause. The volcano pulled the trigger, and the whole system, ocean chemistry, microbes, climate, all joined in. And just when the detectives thought they had the shape of it, the timeline handed them a problem they could not explain.
The problem was this. When did things actually die, and in what order? You would assume, given everything I have described, that the oceans died first. The heat, the suffocation, the poison, all of that is an ocean story. And the marine extinction is indeed the most severe part of the whole event. But when researchers looked carefully at the fossils on land, they found something strange. In many places, the land animals and plants appear to have started dying out well before the big marine collapse, tens of thousands of years before, in some records. That should not happen. If the killer is hot, oxygen-starved oceans, why is life on land dropping first? It is a real puzzle, and it exposed a gap in the story. Slow warming was a decent explanation for the seas, but it struggled to explain why creatures on land, including tough, adaptable animals, and even insects, were vanishing early. Insects almost never suffer mass extinctions. This is essentially the only time in the entire fossil record that they did. Something on land was going very wrong very fast, and gradual warming did not quite account for it. For a while, this was where the case stalled. Investigators had a powerful suspect in the Siberian Traps and a clear mechanism for the oceans. But the sequence of deaths did not line up as neatly as they wanted. Something was missing from the middle of the story. The newest attempt to fill that gap arrived only recently, and it has a name you have almost certainly heard in a very different context. In 2024, a team of scientists published a study in the journal Science that offered a way to connect the dots. Their proposed missing piece was a climate pattern you already know by name: El Nino. You have probably heard of El Nino as a modern phenomenon. Every few years, ocean temperatures in the Pacific shift, trade winds falter, and weather goes haywire across the globe. Floods in some places, drought and heat in others. Today, an El Nino lasts several months to a year or so, and then the system settles back. Now imagine that, but stuck. Amplified and stretched out into something far more violent. That is what the research suggests happened at the end of the Permian. as the volcanic carbon dioxide drove up temperatures. It seems to have thrown the ocean and the atmosphere into enormous, runaway El Nino events. Not lasting months, but lasting years at a time. Mega El Ninos, swinging the planet between scorching drought and violent flooding over and over. And that finally explains the land. Because a mechanism like that does not just slowly warm the world. It makes the climate wildly, lethally unstable. Forests could not cope with the whiplash of flood and drought and heat, and they began to die. And once the forest died, the land lost much of its ability to pull carbon back out of the air, which meant even more warming, which meant even worse swings. Another vicious loop. One of the researchers behind that study, a scientist named Yadong Sun, described the investigation in a way that fits this whole story perfectly. He compared it to murder on the Orient Express. The mystery where the detective realizes the hardest part is not finding a suspect. It is accepting that the crime had more than one culprit, all acting together. That may be the truest thing anyone has said about the Great Dying. Not one weapon. A conspiracy. So where does that leave the case right now? It leaves it, honestly, still open, which is not a failure. It is just the truth of it. Almost everyone who studies the Great Dying agrees on the broad story. The Siberian Traps erupted. They flooded the atmosphere with carbon. The planet overheated. The oceans lost their oxygen and turned toxic, and life collapsed. That much is about as close to settled as deep time science gets. What is still argued in current journals is the emphasis. How much of the killing was straightforward heat? How much was the oceans running out of oxygen? How much was poison gas from those stagnant seas? How much was the methane microbes? How much was these mega El Nino swings tearing the land apart? Different teams weigh those factors differently, and new evidence still tips the balance from one year to the next. They even argue about the shape of the dying itself, whether it fell as one long pulse of extinction or as two distinct waves, separated by a long gap of time. In other words, the detectives agree on the suspect and are still arguing about exactly how the murder was carried out. And given how impossibly old the crime is, the fact that we can argue about it at this level of detail at all is remarkable. There's one more number worth sitting with. After the dying stopped, the planet did not simply bounce back. The recovery took millions of years. Some estimates put it at as long as 10 million years before ecosystems reached anything like their former richness. The Earth did not just suffer a catastrophe. It stayed broken, an impoverished, simplified world for a stretch of time many times longer than our entire species has existed. And when life did finally rebuild, it rebuilt into something new. Here's the twist that ties the whole thing back to the world you know. The Great Dying is the reason for the dinosaurs. Before the extinction, remember, the land belonged to those early relatives of mammals. Our side of the family. They were the dominant animals of their world. And they were among the hardest hit. When the long recovery finally began, the land was wide open, emptied of its former rulers. And into that emptiness crept a group of survivors that had been minor players before. Reptiles that would, over the following millions of years, evolve into the dinosaurs. No Great Dying, no empty world. And with no empty world, those reptiles might never have gotten their chance. The most famous animals that ever lived exist, in a sense, because 90% of everything else died first to make room for them. The asteroid that ended the dinosaurs gets all the attention. Hardly anyone talks about the catastrophe that made them possible, which was far larger and far stranger. And there is a last uncomfortable note that the scientists themselves keep returning to. Every reconstruction of the Great Dying tells the same core story, a rapid injection of carbon into the atmosphere, warming, souring oceans, collapsing ecosystems. Researchers who study this event are quite open about why they find it unsettling to look at. Because the same basic mechanism, carbon in the air driving rapid warming, is something they can watch at a far smaller scale in the present. They are not saying the Great Dying is about to repeat. They are saying it is the most complete record we have of what that particular chain of events can do when it runs all the way to the end. So which suspect do you find guiltiest? The volcanoes, the airless oceans, the poison seas, the microbes, or those endless El Nino years? The people who do this for a living still cannot fully agree, so I would genuinely like to hear your verdict in the comments. The victims are still down there, 252 million years on, turned to stone. And they are still, slowly, telling us what happened to them.